Dear students, in this class let us discuss about an important definition, that is a limit point of a set. What is the limit point? So, suppose X is any metric space or X is any vector space. Let A is a part of X. And any point X fallen X is said to be limit point of A. Limit point of A. Limit point of A means, consider, suppose this is X. And A is a part of X, this is C. Then a point, suppose X is any point. X is said to be the limit point of A if there exists an open sphere X, centered open sphere which is centered at X, which contains at least one point of A other than X itself. Means X is a given set, A is a subset of X, and the point X is said to be the limit point of the given subset A of X. If there exists an open sphere which is centered at X, contains at least one point of A other than at least one point, to may consist of more than one points, so at least one point of A other than X, then that X is said to be the limit point of A. So means the limit X is the limit point of A, X following X is the limit point of A if an open sphere centered at X, that is SRX be the open sphere centered at X, which intersects A minus singleton set X, which intersects A minus singleton set X. Okay. Then the subset A of X is closed. Here X is the limit point of A only when this open sphere centered at X that intersects A minus singleton set X itself. That means SRX intersection A is end. Okay. Now a subset A of X is a closed subset of X if it contains all of its limit point. Means A is closed. Now consider another definition. A is closed if A consists of all of its limit points. A consists of all of its limit points. A is said to be a closed subset of X. A is a part of X. X is a limit point of X when there exists an open sphere centered at X which consists of at least one point other than X. Then the set A is closed. Set A is closed only if A consists of all of its limit points. That means a set is closed if it consists of all of its limit points. Agree? Okay. So now what about phi? Phi is a closed set. Why? Empty set phi is open as well as empty set phi is closed. Why? Because phi has no limit point. Phi has no point. Phi has no limit point. Therefore, phi contains all of its limit points. Since phi has no limit points, means phi contains all of its limit points, thus phi is closed. Okay. Now, by using these arguments, now this definition, consider important result. A set, suppose A is a subspace of X, subset of X, then A is closed. A is closed if and only if A complement is open. A complement open. A complement or A dash. A is a part of X. A is closed if and only if A complement is open. How to prove this one? This proof is that is heavily depends upon the definition of closed and open sets. So first suppose that A is closed. A is closed. That is the necessary argument. Suppose that A is closed. Now to prove that A is a closed subspace of X. Closed subspace of X. to prove a complement is open. To prove a complement is how to prove a set is open. We have to show that a set is open. Then it is enough to show that that set has an open sphere. Okay. So A is closed subspace of X. Since now to show that A complement is open. Let X fall in A complement. X fall in A complement. X fall in A complement means this X is outside of E. X is outside of it. But what is A? A is closed. A set A is closed means it consists of all of its limit points. Since X is outside of A, X is not a limit point of E. Why? When A is closed, A consists of all of its limit points. X is outside of A means X is not a limit point of A. Okay. Actually, what is the limit point? X is the limit point of A means there exists previous case. X is the, consider this argument. Suppose E. So this is E and X. X is the limit point of A means there exists an open sphere. There exists an open sphere which is centered at X contains at least one point of A other than X. Since X is not a limit point of A means there exists an open sphere, suppose it having which is centered at X having radius R, R is positive, such that here it contains at least one point when X is a limit point. So when X is not a limit point means this SR, X and A are mutually disjoint. Means SRX intersection A is empty. Clear? Why? Because of the definition of limit point. When X is a limit point, only when an open sphere centered at X which has at least one point other than A itself. So when X is not a limit point means this open sphere contains no point of A. That means that SRX, that open sphere and the set A are mutually disjoint. Okay, means there is, suppose this is X and this is A, then we can find out another open sphere SRX there. So SRX intersection means SRX and A are mutually disjoint. That means SRX intersection A is empty. Agree? SRX intersection A is empty means this SRX is a part of A complement. SRX intersection A is empty means this SRX lies in where? A complement. Means SRX is a part of A complement. SRX is a part of A complement means A complement has an open sphere. That means A complement is open. So this is our necessary argument. So A is closed. Clearly A complement is open. Agree. A set is closed only if its complement is open. What about the reverse inclusion? Reverse inclusion. Reversely assume that A complement is open. A complement is open. To show, then we have to show that A is closed. Now let X fall in A complement. X fall in A complement. Since X fall in A complement, then what do you get? There exists an open sphere X. A complement is open. Our assumption is A complement is open. Then let X fall in A complement. Since A complement is open, there exists an open sphere centered at X having radius R, which is a part of A complement. Why? Because of the condition of open. SRX is a part of A complement. SRX is a part of A complement means this SRX, this open sphere intersection A is empty. They are mutually disjoint. That means there exists an open sphere centered at X which contains no elements of A. SRX intersection A is empty means SRX and A are mutually disjoint means there exists an open sphere which contains no points of A. Okay, that means X is not a limit point of A. X is not a limit point of A. X is not a limit point of A means X is not a limit point of A. Where X is in A complement. This is A and X is chosen from here. X is in A complement. That X is not a limit point of A means if you choose any point in A complement, that point is X is an arbitrary. So if you choose any X from this A complement, that is not a point of A. That means A contains all of its limit points. All its limit points. Okay. All its limit point. That means A contains all its limit point. It means A is closed. So this is our proof. Okay. So the theorem is very important. A set is closed if and only if its complement is open. This is heavily depends upon the definition of this open and close. Clear? Now consider the closed sphere. What is an open sphere? Open sphere means open sphere is denoted as SRX and is defined as SRX is a set of all y following x such that distance between x and y is strictly less than r. Okay, so this is SRX. This is called an open sphere. This is open sphere. What is a closed sphere? So closed sphere means similarly suppose X is a metric space, A is a part of X, subset of X, non-empty subset of X. Then the closed sphere means it is denoted as SRX. Different in brackets, SRX. And SRX is defined as it is a set of all y following x such that distance between x and y which is less than or equals dxy less than or equals. Okay. So SRX is a closed sphere of X. Closed sphere having centered X and radius R. This R should be positive. So R greater than or equals 0. Set of all y following X with dxy less than or equals R. Suppose R equals 0, what happens? S0 of X equals set of all y following X with dxy less than or equals 0. What is dxy? Distance between x and y. Distance between x and y equals 0. This means x equals y or y equals x. That means y equals x. So that is nothing but singleton set x. So s not x. When r equals 0, s not x is nothing but x itself. So it is always non-empty. That means srx is always non-empty. Why? Because x always fall in SRX. Okay. So this is the closed sphere. So we already proved that an open sphere is an open set. Open sphere is an open set. So what about a closed sphere? Surely in the same argument, in the same way we can show that closed sphere is a closed set. Like that, open sphere is an open set. How to prove this closed sphere is a closed set? SRX be a closed sphere. To prove SRX is closed, to prove SRX is closed, it is enough to show that its complement, SRX complement is open. Why? Because we prove that A is closed, a set is closed if and only if its complement is open. So here we try to show that SRX is, the closed sphere is closed. So it is enough to show that its complement is open. How? So for letter x fall in SRX. X fall in SRX means, or SR, suppose SRX not. SRX fall in SRX or X, what are they? Let x fall in, not x, let y fall in SRX. Y fall in, not simply SRX not. that x fall in SR x naught. X fall in SR x naught means or XR x naught complement. We have to show that SR x naught complement is open. So let x fall in SR x naught complement. That means x is outside of SR x naught. How to define this SR x naught? Set of all y fall in x such that distance between y and x naught less than or equals r. Since x is outside of SR x naught, immediately the distance between x and x naught which is strictly greater than r. Okay, so that means dx x naught minus r should be positive. Clear? Okay. Put r1 equals dx x naught minus r. Clearly, dx x naught minus r is positive. That means r1 is positive. Agree? Now there is a claim. The claim is to show SR x naught complement is open. It is enough to show that there exists an open sphere SR1x which is a part of SR x naught complement. Okay. To show SR x naught complement is open, it is enough to show that it has an open sphere. So SR x naught, there exists an open sphere SR1x which is a part of SR1x naught complement. That's our claim. How to justify this claim? So far, let y fall in SR1x. To show SR1x is a part of SRx naught complement, it is enough to show that this y fall in SRx naught complement. Y fall in SR1x means distance between x and y strictly less than r. Why? Because of SR1x is an open sphere. Agree. But what is dx x naught? By the triangular inequality, dx x naught less than or equals dxy plus dy x naught. By the triangular inequality. So it is less than or equals dxy dx x naught less than or equals dxy. That implies dy x naught which is greater than or equals dx x naught minus dxy. Dy x naught greater than or equals dx x naught minus dxy. So, which is dx x naught. What is dx x naught? dx r1 equals dx x naught minus r, but dx x naught strictly greater than r. So it is strictly greater than r minus dxy. It is r minus, dx x naught minus dxy. Dy x naught greater than or equals dx x naught minus dxy. So it is strictly greater than dx x naught minus r1. Okay, r1 means dx x naught minus r. So what about this one? This equals r itself. Listen, y fall in SR1x, that means dxy is strictly less than r1. Now by the triangle inequality, dx x naught less than or equals dxy plus dy x naught. So means this dy x naught greater than or equals dx x naught minus dxy. So it is dx x naught greater than or equals dx x naught minus, what is dxy? It is strictly less than r1. So it should strictly greater than dx x naught minus r1. But what about dx x naught minus r1? From here, dx x naught minus r1 is r. That means dy x naught strictly greater than r. dy x naught strictly greater than r means y is outside of SR x naught. y is outside of SR X0 means y fall in where? Y fall in SR X0 complement. Okay, y fall in SR X0 complement. That means SR1X is a part of SR1X0 complement. So this claim is justified. So from here, SR-X0 complement has an open sphere. That means SR-X0 complement is open. SR-X0 complement is open means SR-X0 is closed. So the closed sphere is always a closed set. Okay, we already know that an open sphere is an open set. Like that, closed sphere is also a closed set. Clear? So, thank you.